What's up, guys? Welcome back to another Fast API video. This is going to be a long video. I hope we'll be covering the last parts of GitHub Actions, and then we'll be doing things that we have missed out into the 19-hour video. Hoping to catch up with the days I've been not able to record a video. So let's get cracking, so to speak. That was kind of cringe. Anyhow, so last time we were over here. Yeah, so we made this workflow, which I was very proud of. This workflow was called setting up the environment and running tests, where these were our environment variables. I could also name and I could run this on Ubuntu later. I can upgrade my pip, install all dependencies, install PyTest, and run all the tests, right? And if you see in our actions page, you see the last time this action ran, it actually passed, right? You can see the logs, right? So let's
Running
go.
our test, we get a whole bunch of errors, and then eventually you'll see a whole bunch of SQL alchemy errors. And the reason we see a whole bunch of SQL alchemy errors is because if you look at the environment variables, we're pointing to localhost for our database. There's no database on this runner. This is a brand new computer. Why would there be a database installed? So we do eventually have to set up a database for testing on the runner itself, or we would have to point it to a remote database, whether that's hosted on Heroku or AWS, it doesn't matter. But for testing purposes in your CI/CD pipeline, I'd rather create one on our runner that we can just quickly spin up for testing. So once again, I just wanted to point out how to set up environment variables. The one thing I don't like, and I want to make sure I want to teach you guys, is that in this case, we're hard coding these values in here. And so this is all stored in our repository. Anyone can have access to it. This is our test database, so it's not a big deal. But I do want to show you how we can store these as secrets so that the runner has access to them, but no one else can see them, because storing it in here could potentially cause issues. If you didn't want the password and the username for your test database to get out. In my case, I don't really care, but it is important for you guys to understand how to actually do that. So as I mentioned in the last video, our environment variables are hard-coded into our workflow. So technically, when we check this into Git, anyone can see it, which may or may not be a problem. But if it is a problem, I'm going to show you guys how we can work with GitHub secrets. So if we go to our GitHub page and go to settings, here there's a section called secrets. So we can define secrets that we can use and access in our workflows. We can define secrets that we can use and access in our workflows. And so this is a repository secret. That means it's globally accessible across the entire repository.
What? I'm assuming therefore. So secrets.
Repository across all branches. There's no, any kind of environments or anything like that. So we'll select new repository secret. And here we just give it a name. So if you take a look at our environment variables, I figured since that's what it's going to represent, we might as well use the same one. So I'll say database host name in this case, and then just give it a value. So localhost. That's it, right? It's just a key value pair. We do add secret, and then you'll see it's stored in here. And so now,
Okay, add secret. Right, I can also edit this. Oh, I can update it, so I can't really change it, so to speak. Okay, update secret. Uh, okay, cool. So we have secret key, and then we have algorithm. Right. What's the difference between environment secrets or repository secrets? What's the difference? Receiving and read stack code. Okay, so I guess more or less, right? Let's go new secret. This one be 60. Add secret. Let's go new secret, which is TV name. I don't know why I'm doing that, but chalo, theek hai. So you have a bunch of secrets that we have written.
In our code, if we want to reference the this secret, which I happen to call database hostname, we just copy the name of the secret, and then what we do is we use dollar curly brace, so two sets of curly braces, and we say secrets dot and then the name of the secret. So this will allow the runner to access the secret from our GitHub repo so that our workflow code
Um,
doesn't actually expose all of this information.
okay, no wonder
And so
everyone.
this is what you want to do for your passwords and things like that, especially when it comes to storing the information for connecting to your production database, which we will do in one of the later lessons. But before we proceed any further, I want to actually show you another option. So I'm actually going to remove this repository secret in this case, which is once again a global secret that our entire repo can access. Instead, what I like to do is I like to set up environments. So you can set up a whole bunch of secrets that are available depending on what the environment is. So I can create one for testing, one for development, one for production. It gives us a lot of flexibility. So I'm going to create a new environment, call this testing.
Okay, let's just see if this runs though. So, uh, testing repo secrets on workflow. My bad. Push. Okay. Um, let's go back to actions. This should be running an action right now. Let's see what happens. So it's installing. The only issue I think it might face, yeah, so it might face issues in, oh, it did pass. Cool. Yeah, so it works.
And within the environment, we're under the testing environment, we can add a secret here. And so we're going to do the same thing. I'm going to call it database hostname, and in this case, we'll say localhost. We'll add the secret, and we can provide as many secrets as we want. And then what we can do
Essentially, what I figure out is to get things running on your own machine, you will need to have a .env file, and in order to, in this case, you can use Pydantic to get it, and for that we'll have a config.py, which essentially goes onto the .env and takes those things and uses them. Right, essentially that's how it does it. Um, and then we use Pydantic to verify that the type is matching, and so if for your own local production, you will always have a .env file. But whenever you're doing for prod or dev, you will always have a way to inject these environment variables in some form or shape. So makes sense.
is in our job, we can specify what the environment is for the job. So I can say environment,
It's a do I have
and
GitHub?
then we provide the name, which is going to be testing, right? This is going to match up with whatever name we gave here. So I called it testing. So we give this the name testing, and it's going to have access to all of the environment variables that we define here. And the way to access them is exactly the same way. You just do dollar, two curly braces, secrets, and then the name of the environment variable. Now, if there's an overlap with the name of your environment variables when it comes to the ones that you set in your environment, as well as the one you set globally for the repository, I don't actually know who takes precedence. I suspect it's probably the environment, but I should check the documentation to verify. But we don't have any global secrets. I'm going to be using environments for everything, so this keeps things nice and simple. And so now that we've set up this one, let's go ahead and just set up all of these while we have the option. And so now that we have all of our environment variables or our
So you can just.
All right, and so now that we got all of these set, let's just save this, and I'm going to check this into Git now, just to make sure that everything is kind of working so far. And we'll take a look at the job real quick, and hopefully there's happened there, and it even tells me the mistake. I forgot the secrets dot before all the
Okay.
will automatically kind of hide what all of the secrets are,
Oh,
because once again they're secrets, so you shouldn't see them. But it does show that we were successfully able to retrieve them, and we got this again. They're kind of
really? What is he doing differently then? Uh,
hide what all of the secrets are, because once again they're secrets, so you shouldn't see them. But it does show that we were successfully able to retrieve them. All sorts of issues. So
yeah, I mean, um, I'm hoping that's how it works.
next video we'll figure out what we can do to set up a test database on our runner so that we can actually run our tests. So when it comes to setting up a database on our runner, the easiest way to do that is to create a service container. So what's going to happen is GitHub Actions is actually going to allow us to spin up a Docker container, which really is the easiest way to set up to set up Postgres on a remote machine. That way we don't have to worry about any issues with potential installation of a Postgres database. And so I recommend you take a look at this tutorial, which kind of walks you through how to set up a Postgres service container. And it just gives you an example in this case, which we are essentially just going to copy in this case. But here we just, under jobs, we specify a service. We give this service a specific name or label, and then we just tell the image that we want to use. And in this case, we're just using the default Postgres image. This is the one that comes from Docker Hub, by the way. So you could technically use any image that you wanted to, but it's Postgres, so we might as well just use the default one. And then we can pass environment variables into the Docker container as well, as well as even some health tests. Exact secret, because and then we also want to give it a custom underscore thing. You have to specify the ports that we want to open up. Why it didn't work, but for some reason this wasn't allowed, so checks for sure.
I do feel like I should have gone with Postgres as a database for this one. Sadly, it seems like I went for the trusted old to-do.db and test.db, and then I have schema, right? Because that's great.
Let's save this and make sure that all the spacing lines up, because a lot of times the spacings can mess up things. I have a auto formatter, so for YAML syntax, it'll automatically
Oh,
format it so that all the spacing is set up properly. You want to make sure that you do it manually or set up or install a extension in VS Code if that's not for you. Okay, so we've got our Postgres database. All right, and so we can see that our CI pipeline, this is the CI portion of things, to pull our code, install Python, set up, install all the dependencies, and to run our tests. So all of this happens in an automated fashion now just by doing a git push. So you can see how easy it is to get things started. And so I think from the CI perspective, the last thing I want to show you guys is how to essentially create a Docker image in our runner and push that out to Docker Hub so that our production network can then pull that brand new image. So there's a couple things that we have to do to get Docker working in our GitHub workflow. The first thing is we need to have a repository set up on Docker Hub to store our images. And if you didn't create one during the Docker section, go ahead and create a new one. So log into Docker Hub, select create repository, and
Uh,
just give this a name that you can remember. In this case, this is going to be FastAPI. I'm going to call it that, and then make it public just to keep it simple. And so this is our repo, and then it's going to tell us how to actually push an image. To it. And then if you go to this page right here, so docs.docker.com /CICD/GitHub Actions, it's got the an excellent tutorial that we can follow. Access token. So let's go here, and I think we go under settings, or well, it doesn't look like it's here. Maybe account settings. Yep, and then security, and then we can select new access token, and maybe we can call this GitHub Actions, and we're going to give it whatever permission that you want. Does the Docker, and we're going to maybe we can call
well, this will generate this. Cool. Okay, successfully created personal. Um, okay.
all this. It doesn't look what you want. Does the Docker give us information on what permissions? It doesn't look like it. in this case. So just go ahead and select all of them for now. All right, and so it's going to give you your access token. Make sure that you don't share this with anyone else, and it's only going to be displayed once, so go ahead and copy it to make sure that you have this. Then what it's telling us to do is we want to create a secret for both our username as well as the Docker Hub access token. So let's create these two secrets in GitHub for Docker Hub access token and Docker Hub username. And I actually forgot what my username was. Okay, so it's sloppy networks. And so here we'll go, okay, so it's sloppy networks.
I'm assuming that's my username. So anyhow, add secrets. So we have access token. These are the linear Docker. Okay.
And so here we'll go into settings. And feel free to use either the global repository secrets
I don't know
or
what to really do with that.
environment secrets. I'm going to just put this in the testing environment for now, but you can use either one in this case.
Like I'm assuming this Docker.
And so we got docker underscore hub underscore and file. You can ignore the original, shows us how to log into Docker Hub. So we can literally just copy this. We'll do it at the, what step should we do this at? We'll do it at the end just because why not?
Shouldn't we make like a different job? But every job runs independently. Okay, so. Right, so essentially we could essentially copy this, right? Just um, okay, so this will do the login to Docker Hub. Set up Qmon. What does Qmon mean?
Because some of you guys might not be in two properties, username and password. So we'll set up Docker build X. So we'll copy this one as well. Right, and then we have the build and push step right here, which in this case, it's once again a built-in action. And all it's going to do is we're going to provide a path to the context. So this is essentially where is the Docker file located. And this is technically optional, but if you want to, you can hard code the specific Docker file. I think it should default to this one because that's the default Docker file, but we'll just put it in just in case. And then the push means not only are we going to build the Docker image, we're also going to push it up to Docker Hub, and then we have to give it a specific tag. And if we go back to Docker Hub and I go to my repositories and I go to my FastAPI, it's going to show me the format of the tag repositories specific tag. And if we go back to Docker Hub and I go to my repositories and I go to my FastAPI, it's going to show me the format of the tag that I need so that I can actually push it up properly. So it's going to be the username slash and then the name of the repository, which is FastAPI, and then we can also give it an optional tag name as well. So once again, we're going to copy this and just update a few fields. Everything else should be just fine. The only thing that we have to change is this is going to be FastAPI, and it's going to reference the username. So it's going to be in the exact format. And if you want to give it a very specific tag, you can give that as well, but I'm going to just give it the default latest. And then here it's just printing out the image digest, which is for us is optional. You'll see that it does provide us some printing out the image.
It's kind of true. Yeah, so at the current directory essentially.
That is the only thing that we have to change is this is going to be fast API and it's going to reference the username. So it's going to be in the exact format. And if you want to give it a very specific tag that I need, so that I can actually push it up properly. So it's going to be the username slash and then the name of the repository, which is fast API. And then we can also give it an optional tag name as well. So once again, we're going to copy this and just update a few fields. And the only thing that we have to change is
They changed that.
this is going to be fast tag. You can which is for that as well, but I'm going to just give it the default latest. And then here it's just printing out the image digest, which is for us is optional. You'll see that it does provide us some optional things that we can do for optimization. So we can use um, the build cache so that we don't have to re-download all of our images every time we run, because that's going to extend the build time and the run time for our runner, which is eventually going to cost us a certain amount of money. So this is the code that you can use. And if you look at the bottom right here, this is going to show us all of the code at the very end. So we can literally just copy all of this if we wanted to and just use that instead of what we put. So that's what we will do. So let me just delete all of this and then paste it in.
Oh, what is this?
Once, and that should be all that we have to do for.
And then this God knows what this section is about. Okay, even if I run this, it's gonna be horrendous. भाई तो हटा ही दो ना, एक वही करना है तो करते रहो एको.
root in the root of your project directory. Well, I'll just pause this video create a file in your root, in the root of your project directory called Docker file with a capital D, and just copy all of this, or you can follow what I go through in the Docker section if you guys skip that. And I think that should be everything that we need. So let's go ahead and push this and pray that it does not break anything and it works just the way we expect it to. So we'll do git add -- all, git commit added Docker, and then we'll do a git push origin. Yep, and it failed. So fully expected this. A step cannot have both uses and run keys. So what did we break here? Actually, it should, where is it telling us this? Yeah, this spacing got messed up. So that was a very obvious mistake that I should have caught. I just have to move this back right there, and that should fix everything. So let's do this again. All right, so far it's not errored out, so it looks like things look okay. And we can see the build and
Okay, so we did manage to set up Docker. We did were able to wow, it seems like this might work in the first try. This is kind of crazy. Okay, this is our, let's keep this reloaded. Let's see what happens. Hmm. Wait, actually it worked. Uh, wait, actually, what the hell? Oh wow, it did work. Less than a minute ago, were able to. Wow, latest. And the reason why it says latest is because, as you can see over here, latest and OS is this image. Wow, that's crazy. So essentially right now our workflow does is after it has run test successfully, it essentially logs into Docker Hub using our username and token and essentially builds the image, and after it has been say pushes it, and it creates the Docker file for this based on our Docker file. Creates the Docker image based on this Docker file, which is great. Um, wow, that's crazy.
push section failed. So if right after the login, if we do a git right after the login, git first log into Docker using the login, just saying just this current directory, and then the location of our Docker file.
Is
So we're
Docker.
going to use buildx for the builder, and we set push to be true because we want to actually push it to the GitHub repo, and then here the repo is going to be our username slash then the repository name, which is happens to be FastAPI. We could store this in a secret, but I decided not to. And then these are just copied from the documentation so that we can cache all of the images, so that we don't have to keep running all of this from scratch, which is a fairly long process. And then here we're just spitting out the image digest. And We take a look at our workflows, and we can see that the last one, which I just called ASDF, successfully ran. And if I actually go back to my Docker Hub in this case and just hit refresh, right, we can see that we did successfully push an image a minute ago. So that means we have now successfully completed our entire CI portion of our CI/CD pipeline. The next step is to set up the continuous delivery, which is a matter of just providing a whole bunch of commands needed to actually push out our new code to our production network. And moving forward, just to kind of keep things simple and as quick as possible, I'm actually going to copy out all of the Docker steps because we're not even using Docker in production, so we don't actually need this. So we'll just comment that out just to make things as quick and as snappy as possible. So that we
I think now what really matters is to improve our tests, because our tests are horrendously bad. Like our test route is fine, like this works. Our test post, let's just say it's it, right? Right, no assertion there to begin with. I heard someone said skip CI, so I could say git status, git add, git commit, minor change, skip CI. Okay, git push. This is run the CI. Okay. Let's check. Does this run the CI? Oh, it does not run the CI. So as you can see, in the latest commit, we do skip CI. Okay, that's good because I don't obviously.
too many of our build
Yeah,
minutes.
that would be like kind of
So now that we set up the continuous integration part of our CI/CD
weird,
pipeline,
right?
it's now time to move on to the continuous delivery aspect of our
Um,
CI/CD pipeline. So this part is going to be responsible for pushing out the update to our production environment so that our code or our production environment is running our newest and latest code. So there's a couple things we now to make our login user test independent of any other test, so it's not reliant on a specific order or setting the fixtures to
okay,
a
so
specific scope. What we do
test
is put our log.
test logging user and way too ahead, right? Um, Click over here though. I don't know why I went to 16.8.
So we've got our create user test pretty much done. You can feel free to customize it however you want. If you want to add a few extra
Actually,
statements, feel free to do that. But we're going to move on to login. So let's actually handle setting up the login. So I'm going to do def test underscore login underscore user. All right. And this test is going to be dependent on the client fixture because we need to be able to send a request. So I'm going to pass in client. And I'm actually going to copy this line right here.
mm, yeah, so we would, yeah, surely like this is login especially. I hmm, logged in client essentially, like, right? Ugh. We have a token which for JWT token. If you click on this, yeah, so we have access token and token type. And if you actually went to OAuth, you would see what we do over here. It's quite similar, right? That is over there, but the main I think is over in auth. So you have a return auction type, and this is essentially what referred to as in token type, right? So I don't know how will you do it. So okay, just give me a moment. I'll just wash my face. It's sweaty over here. Back at it. Yeah. So let's see how he does
Speed, of
this.
course, but all right. And so we're going to, this is going to go to slash login. And there's no trailing slash on this one, just because if you actually look at our specific route for login, I think it's under auth.py. You can see there's no prefix here. It's just slash login. So we don't need the trailing slash on this one. You just have to figure out how you set yours up and make sure it matches accordingly. We don't Postman, and you want to, we do slash login. But in this case, we don't want to send this data in the body. Instead, remember, if you go to Postman and you go to login user, we don't send it in the, well, we do send it in the body, but instead of using the um, normal JSON format, we have to send it as form data, remember? And so to change this to be form data, you just change JSON to be data. And we've got the same credentials.
Mm, yeah, I mean, I'm still using that for creating a user. We're still using that. It was a personal decision. Oh no, I will do that. Can this thing open? It does not open.
So this should work. Let's just quickly just do a assert. And what does a login return?
Yeah, so like, okay, let's look at what login actually returns. I think it's in users. Uh, in auth. Yeah, so yeah, so we have login. So login can return a status code. Let's do this very simply. Find three of that. I think. Go to PyTest. Test users. Uh, PyTest. Test users. So it fails on what? What? 59. Exactly. Oh my god, this is my bad. Um, test new user, I guess. That should work. My bad. CID test new user. Okay, yeah. Now that will work. Let's go. Yeah. So okay, that pass. If I were to let's go print res.status code just to see what happens. I'll see 403. Yeah, because that's not.
A login.
What else does this thing gives? Um, yes, we could have invalid password as well.
Returns a, and it should
Let's,
just be 200.
I want to see what happens. Like, this is interesting. Let's go WSL. Um, WSL open up. So I guess we would do something like SQLite 3 app do.db and we'll do mode box header on and we'll do select start from users. Okay, so we have these many users. Um, hmm, this is very hacky. Uh, you know what? Let's do something like Ibrar. Actually, because I do use the same. something like this. I want to see what happens, right? Because you never know, it might actually work. So, my bad. Let's just do this. Okay. Let's try this again. 403. Um, hmm, was um chat. This might work. Let's check. Given email does not exist. Which is it actually does not exist. It's kind of crazy, right? I'm assuming this is different. It does exist though. Um, okay. Ah, fuck! It uses the test.db. My bad. It uses the test.db. I was looking in the wrong test folder. My bad. SQLite 3 app test dot. Uh, no users. Yeah. So
100. So we'll do a 200 assert res dot status code equals 200. All right, and let's test this out now. And it looks like we got an error. So what happened here? Let's take a look. It looks like we got a 422
422. What the hell?
as our status code. Why would we get a 422? And if we take a look at our logs, we don't really get much information here. So what I'm going to do is we're just going to print, right? Why did we get a 4? Well, look at this. There's some sort of validation issue. Detail type value error missing. So it's not actually called email. It's called.
Ah,
All right, we get another failure. So let's see. This time we get a 403. Okay, interesting. So what's happening? Why did we get a 403? Let's see. Detail says invalid credentials. Interesting. So if I go back to my login route,
I just forgot that we use a test.db. Test underscore to do.db for our testing purposes and not actually to do.db. It's like, wait a minute, Henny. And the reason why is because every time, essentially every time this is completed, every time client is used and the function returns, it actually runs this code, which essentially just goes to the connection and then just and I'm not closing the connection. Actually, I don't need this. I don't need this. Okay. Let's. Yeah. So okay.
Right, you could see that we get a 403 if the user doesn't exist, which means we couldn't find a user with that specific email, or if the password that was provided doesn't match what's in the database. So this is one of the issues. It's either the user doesn't exist, or the email doesn't exist, or the password's incorrect. So let's go into pgadmin, and if you left your end, so I'm going to refresh this, data all row, because if I go to my code, during our test create user, we should have created a brand new user. So why can't we log in as this user? Well, that's easy to explain. So if I actually go to my my database.py, we have these fixtures, and the fixtures have a specific scope, which means when do they run? And right now they're using the default function scope. What that means is they're going to run before every single function that's dependent on them. So that means when we run test users, right, we can see that test root client, right? Since we're passing client into test root, we're going to run our fixtures before we run this function. Then before the next test, we're going to run our fixture again. And then before this test, we're going to run our fixture again as well. So why does that actually cause the user to get deleted? Pretty simple, because we run this test, right? The test create user, the user's in the database, and then we start to run the test login user. And so since we're dependent on the client fixture, we go to the database.py file, we can see that the client calls session. Session, what does session do? Well, it drops the database, or it drops all the tables at least, and then it creates all of the new tables. So we get a brand new database every single test that we run. And that's why the user isn't there. And if you want to learn more about scopes, I recommend you go here, and then I think, if I go to API reference, I think, and then fixtures, let's go to examples. Right here, right now, is that our scope is functions, which means that the fixture is destroyed at the end of each test, and it's run for every single function. Once we then have a fixture that's set to a scope of class, which means that it'll run once per class, and it'll run all the tests in the class. Then we have a fixture module. So when a fixture is set to a module, that means for all of the tests in a specific module, right, like in this case, all of the tests here, we're going to run the fixture just once at the beginning, and then we're not going to run it again for that module. So all of the tests will have access to just that first instance run, essentially. And then we also have it for package, where it's going to run once per package, and then we also have session, where it's going to run
This is getting
once
boring.
at the start of the testing session, and it's going to get
Yeah, I guess I'm gonna stop this. What could we learn? I was seeing this. Yeah, this one. I actually want to like building a type agnostic C library. I think we'll do this because I'm getting a bit bored, to be honest. Like I'm getting a bit bored. Let me just turn off my Docker
Guys, this is starting to annoy me a little bit. If you're new to C programming
and
and
we
you
just
Google
skip it.
something like linked list, then what you're going to get on the first page of Google is literally all just like.
Let me just close this up. If we were to do git status, and if we were to do git add, and we were to do test login users in test users.py, git push, and also if I'm correct, this does run, right? So my test should work, right? That shouldn't be an issue. Yeah, it's running at the moment. Let's see. Getting a bit bored, to be honest. Um, let's see. Hmm, the issues. Yeah, token का use करेंगे. Don't worry about token. We'll use token. Yeah, seems like um my test that ran. That's great. Um, I love C programming. Like to some extent, I do like it. It's kind of like something that fascinates me. Um, right. So I guess that's the case. Let me make a folder and come back to you guys. Okay. And we are back. So yeah, I'm very much interested in this video. I wanted to find a reason to watch this. Even if I don't understand it, it's gonna be fun watching it, right? Let's go.
Like int item,
I think you guys
int
can hear it.
font, int data. Even learnc.org is int val. And it's like, okay, storing integers in a linked list is cool if you're just trying to learn how a linked list works. But when you actually need to write a real program that works with real data, storing an integer is not actually that useful
It's
unless
true.
your specific use case is storing a file descriptor or something like that. Usually we want our data structures to be able to link to more complex data types. And so how do we do that in something like C, where it's all kind of very strict on us? The solution to this is a void pointer, and you'll notice that the C standard library actually uses void pointers everywhere in order to give us a type agnostic API. So what we're going to do is essentially use this technique ourselves on our own personal libraries and data structures that we want to build. To demo this technique to you, I've got two elementary data structures. The first one is a linked list. Now let's look at our implementation versus the ones from Google. You'll notice that the data type that I've specified in my linked list node is not an integer.
Okay, so um, I'm seeing a lot of code. I'm a bit scared, but nonetheless, we'll try to figure out this. So I'm just gonna read this. We have struct linked list node, which points to something. Normally when you have this, it's something like of the scope of include standard IO int main. Yeah, so just return 0, I guess. Yeah. Normally when you do such stuff, you say type def. I'm not doing type def, and yeah, here's type def. You would do something like yeah. I mean, I would do something like type def struct node, and it would contain something like valve and struct node star next and node. Yeah, so this would be a typical value. So you would have like a bunch of memory allotted, so to speak, right? It would be just now trying to like figure out each point. So you have like this much amount of memory, which this memory just contains the int, which in some could be 4 bytes or 2 bytes, and this contains a pointer, which is essentially pointing to none or nothing, right? But over here, this place, and so this is the same cheese here, but over here we could have we are essentially having a pointer that essentially could point to any type which we don't know of. That's why we have a void star, right? And that is the reason why whenever you do like something like malloc, um, standard.h, that's the reason why. I mean, for me, when you do malloc, you have to do this like this int star, which is like telling it like okay, because we're the return type we're getting is just give me this 2 minutes. Uh, um, sorry, my bad. Int star. Yeah, so essentially if you hover over malloc, you'll see the actual definition of malloc is you get void star, and so we have to like type type hint it or like type converted to like, okay, now that malloc, I mean, technically void star is not pointing to any random type, it's pointing to an int type, right? So that pointer is pointing to an integer, and that's why this works. But in his implementation, we won't be doing this. So we would be doing something like, we do something like void star, which is the problem with void star is key. Let's say you have a pointer somewhere to an type. If you inform that type to the C compiler will know how many bytes to go ahead to read, right? Because if an integer is 4 bytes, so it has to read 4 blocks, right? Assuming one block is 1 byte. But when you say void star, well, it doesn't know how many bytes it has to read in order to get that data. That's why it's such a hassle, right? And this, let's say, CD worked. Okay, cool.
It's a void pointer. And what I've actually got down here is a struct that represents the state of the linked list itself. Why do we need a state struct all of a sudden? Well, here's the trick. What you need to think about when you're designing a type agnostic library, you need to know everything you can about that unknown data type except for the type itself, because that's the thing that the compiler is going to bite you on. So in terms of a data structure, what we need to do is we need to know the size of the data, and that's what we collect here in the metadata for this struct. So the user of the API can provide the size of the data. And this is common across other functions, like if you use memcopy and stuff like that. They all need to know the size of the data that they're operating on, but they don't necessarily care about the data itself. Now, with a linked list, it gets a little bit more interesting because sometimes we do want to care about the data itself. For example, how are we going to walk our linked list and search for a value? Well, that's where the magic of function pointers comes in, where you pair it with a void pointer. And this is a technique that's used, for example, in the C standard library binary search implementation, which is where you simply provide a compare or matching function, which is user specified. So when you initialize this linked list, the user can provide a matching function that takes in data structure 1, data structure 2, and compares the two to see if they match. So for example, if you define a struct, and I've got one over here. So what we're going to be testing this linked list with is my wicked data structure. And my wicked data structure has a key and a value. And I've got two examples of match functions here that we could give to our linked list search. The first one is just based on the key comparison, which is the integer. And so, for example, what you do with the wicked match is you take in your void pointers, because obviously that's what we need to do, and you cast that to your proper data structure type. And once you've casted it, you can actually access the struct members. And that is the trick that lets the compiler be happy with you. It's essentially like at compile time, everything that needs to use that data still knows what the type is because you do the cast. And to be fair, you do rely on the user to be accurate with their APIs and their initialization and everything. But the data structure library does not care about the underlying data because it never has to use it. What it's going to do is reach out to a user-specified function which does know what the type is. And that's kind of the whole trick here. And so when you come across complete vibe-coded slop, like the Zero Lang repository from Vercel Labs, which has a lot of C that I've had a little bit of a look through, and you come across something like this, which is where they've got a function vec type and a shape vec type, which are identical except the pointer that it stores, you can know that there is a much better way to do that if you weren't completely vibe coding it using AI. 4.1k GitHub stars, by the way. Now, how does our library actually work with the void pointers? It's cool that we can write that in our node over here, but when it comes time to actually insert that into our linked list, how does that actually work? We come over here to this ll insert function, then the first thing we're going to do is alloc the node container, which is this whole container here. And then if you come over to this section, this is where we actually work with it. I've got an option here, which is BYOM, that's bring your own memory. So when we're writing a data structure like this, typically I like to code for two scenarios. The first scenario is where the calling function or the caller is going to own the memory that that element is stored in, and we're just going to copy a reference to that. And so what this allows the caller to do is hold that struct in a buffer somewhere if you want to pre-allocate all of this memory, and simply pass the pointer to that, and the pointer is what's stored here. And so it's the caller's responsibility to clean that memory up. You can also do basically a copy container.
Okay, guys, this is well beyond my skill ceiling. I'm having tough. I'm having a tough time um, like reading through this one, you know.
And then we're going to search with the int compare. So the int compare is this first one here where
Yeah, this makes sense because just give me 2 minutes. Think we should learn about function pointers. Function pointers in C, because one of those things I think the most common sense thing would be key in some part. Whenever you write a function, it's just bunch of instructions which are stored as some part in memory, and so function pointer would just be like pointing to that function, right? Like function pointers in C. Let's start with basic. Why free words? No need. Let's start with the basic function which we'll be pointing to. So we have this basic function which does add int. First, let's define a pointer to a function which receives two ints return int. So this is the function pointer, right? So if we were to be something like, let's go something like, if we say int add int, and we say int a, int b, and this focus on my word. This returns a plus b, right, in effect. So in order to make a function pointer, we say int function. Okay, it's a function pointer that takes in two ints and returns an int. Now we can safely point to our function. Okay, so it pretty much is int star fptr and int. Okay, and we can say add int of some sort, right? Now that we have a pointer to a function, let's use it. And so the way we use it is we say int sum. We basically call it. Passing the pointer to another function is basically the same. And okay, so we do in star function pointer, and so now we do that. That makes sense. So I could do something like printf. I can say because it's a function pointer, I have to always state it ftr11, right? And this will have I, and let's just open WSL because it's much better to work with. So we have function, the syntax of the different thing pointers. So at make main main. So we get two. I think I can do something like make main and main. Um, yeah, okay. So that is how it works essentially. So this is how we initialize it, right? And this makes sense. And actually, sometimes you do in star array, so this is much easier. I think you remember, right? In star function pointer int add int, right? Passing the pointer to another function is basically the same, so we essentially just do this. We can use function pointers in return values as well. Try to keep it up, it gets messy. This is a function called function factory, which receives parameter n and returns a pointer. There's a function called function factory which receives parameter n. This is a function called and returns a pointer to another function which receives two ints. Okay, buddy. I don't. Is this required? Okay, so it's int. Why is C so cryptic in that sense, right? Why is like it's genuinely so like tough to see through? What is this? CMS. Who is this? Oh, let me just lower my mic because this disturbance. Is like yeah, so when you think of programs, they have a bunch of memory. You have at some point the heap, you have some point the stack, you have code, and you have all that. So in that memory, you have functions. And I like how they say, let's say you have a sorting algorithm and you don't know which sorting algorithm you'll use because let's say n value is less, you'll use insert and sort, n is large, you'll use quick sort. So how do you do this at runtime, right? Because at sometimes you have to use a function. In a way like you could think of it like um, yeah. So assuming I take an array of ins and return those array sorted, do something like in star sort in star array, and I can say some form of like sorting algorithm, and um, sort int array, and this essentially does that. And like mm, what is this? Why is this? There's that. Okay, okay, right. Else for now also we return. Right. So what the hell, bro? My bad. Um, Yeah, so this essentially sort int array, and so we can take a bunch of arrays, and then over here we can take like in some sort a function for sort, which will take in those and return us the instant with that. So that could be used in that sense, right? Functions like variables can be associated with address in memory. We call this a function pointer. A specific function pointer variable can be defined as follows. So this essentially means कि fn is a function pointer to a function that returns an int while it takes to int, right? That's how this thing's said to me, right? Right. Uh, yeah, so that's pretty much how that works, right? Here we define a function pointer fn that can be initialized to any function. That's the very keyword, any function that takes two integer arguments and return an integer. Exactly. So what that essentially means is if I, let's say, have a sorting function, so to speak, which again takes an int array and returns an int array, right? Just for the namesake, I will do what I can do is I can again, did I remove that? I didn't remove that. um, I could do something like, so it returns an int star, and it's a star um, um, sorting function pointer, and it takes an int star, right? Something like this. And we could pretty much give it on sorting function, um, right? This could work. Okay, this works. So this means key this function itself takes an returns an int star and takes an int star itself, and so this pretty much works very well for that. So this is our sorting function, and we can say it over here as well, right? We can say, well, so we want a function that returns int star while it itself is a sorting function pointer while taking in an int star. Um, uh, what the issue is? What function returning function is not allowed, but it's not returning anything. You said that how we can, anyways. But that is how you said, right? We can pretty much use the same. Doesn't that work that way? We just returned that, to be honest, right? Is that not working the way? Am I doing something wrong, chat? Um, okay, let's do a very interesting thing. Function takes an int star function pointer takes to int. Does that work? That works. Does this work? Um, int star. Um, Okay, so this returns an int star, that means an array, and takes a bunch of array, and this is our sorting function pointer essentially. And so we'll call this pointer essentially to sort our array. So let's do one thing. Also one more thing, int length of the array. So this takes int the length of the array also, right? So this wouldn't be correct, so to speak. If I run this, you will see, initialization of int star from a computer type of int star int. So this already takes an int, right? So to do something like, right, int, and so to speak, let's do one thing. If array is equal to null, or len is equal to 0, we will just actually, yeah, okay, uh, return null, else uh, Python return null as well. Okay, so let me give simple most sorting function in C. I think bubble sort, right? Bubble sort is the most simple, the built-in quick sort. Uh, yeah, so pretty much that what we can do is um, for int I is equal to 0, I less than n minus 1, I plus plus, right? I is equal to 0, I, and then we can do for um, C length. I can say int j is equal to 0, j less than len minus 1 minus I, j plus plus. This is how it works, right? And then the actual logic, um, right? You don't really need to do that, to be honest, like, because it's int, right? If array j is greater than array j plus 1, what we can do is we can say array j is, this is a bit of a hacker magic, XOR technique, right? Um, that is a bit of a hacker magic. This does the swiping for us without using any extra memory, and yeah, this pretty much does our bubble sort. And after this, we will just return you array. I think that should work, right? Yeah. So let's run this. Yes, nothing happens because that works. Cool. So this essentially is, we'll say bubble sort, right? And bubble. So now we can, and now this takes in this, but we could also have, this is the fun part. Um, I mean, to be honest, if length does not really allow us, that's the fun part. We can also have multiple of these stuff, but I won't go through that because if we read through this. So yeah, this could pointing variable this is now to initialize fn to the address of the sum. We can do the following because obviously we know the ampersand, the symbol gives us the address of practically anything, or simply this. Just ignore the and function names. It's just like array names. They're pointer structure they're referring to. Oh wow, crazy. So function names are just like array names. They are pointers to stuff. Oh my god, that's interesting. So that's interesting actually. Normally, what happens is when you actually say, okay, so here's some fun things that you will not know about. But yeah, what it means by this is, let's say I have an array, right? And I have an array of 5, and I say 1, 2, 3, 4, 5. Or I just say, right, if I run that, nothing happens. But if you actually try to print f, I, actually p, and you actually just give a, if you see, it actually prints an address. And funnily enough, if you run this with, um, you see both of the address will be same. Both address will be same because a is nothing but a pointer pointing to the very first element of the array, right? That's why they say you could do that. That is interesting. So we either use the sum function in two ways. We can actually direct call it, or we can call it like this. So that is how we call it essentially. And so the way we can essentially call this is we can say return s ssbtr, right? And we given the array and we given the length. So length तो कोई लिया नहीं है अभी तक. Int length um, and this can take the length, right? So now we essentially have this function which essentially does this thing. So let's see if this works. So if I have an array of 5 and we say 1 2 3, let's just do 5 4 3 2 1, right? And if I do something like, um, I mean, essentially it does this, like does it does basically does that. um, this could essentially be just void because we're actually making the change. So I can put this as void, and I can do something like sort in sort int array a 5, and you can actually just give the address of bubble sort, right? Hopefully this works. Cross fingers. Okay, bunch of errors. Great. Let's see what this thing. The first thing is it is 16. Interesting. Return with a value is function int function returning void. I. Yeah, that's point. Um, okay. But it was an in place sort, so I'm assuming if I say for int I, can we increase the size of this font? It's hurting my eyes. Yeah, if I do something like for int I is equal to 0, I less than 5, I plus plus, print f, and we'll do a of I, fingers crossed, yeah, this works. Um, it actually does work, and also let me just comment this out. Yeah, it does actually work. That's great. But we don't necessarily need to do in start, to be honest. Like the thing is that this is actually in bar sort, so what we could do is just make this void, so to speak, because it's in place sort. and what that means is you'll change this also. So say this could be void, and right. What's the issue now? I don't think anything will be issue, and we have an issue. But we'll sort. Why is that a problem? Yeah, so it's not a problem. I don't know why that previous error came. Yeah, so we essentially made a function which can point to any function with the following function prototype and can allow us to pretty much do that. That's great. Let's just consider the following mystery function that takes three arguments, two ints a and b, and a function pointer that tells mystery what to do with the two ints. So essentially over here what this means is we have a function that takes two integers, and it takes a function pointer that returns an int while taking two ints, and then we say return fn star a comma b. Now let us define two functions, gcd sum of squares. We can call mystery functions gcd and sum of squares or sum function using type defs. Syntax of function pointers can be confusing, so we use type defs and turns to make things simpler. So we have type def, return type, function pointer, argument list. So we can define a variable of type f pointers as follows: f pointer fp. Another example, type def int ptr int in. So ptr fp is equal to sum. That is interesting. So uh, hmm. So in that sense, I could do something like type def hmm, void void uh, void function pointer while taking in star and in, right? And uh, right, so void star, okay, and then we can do that. Achievement. So like over here, instead of this, I could essentially just say something like void function. The problem here, interesting. Okay, it's actually okay. This is better, but let's just do something like a dot c for some reason. Anyhow, standard this. So yeah, exactly. We could have sum int a int b, and we can return a plus b. And now a normal function pointer would go something like int star f ptr takes int sum. And the way we would run this would be something like yeah, so ft, right. And if I say make a, what's the issue? So issue here. What's the issue? Ah, my bad. Yeah, all those years of uh so essentially of doing this, because something like type def takes an int pointer int and we get something like fptr fs is equal to mm, fs. This is work. Let me make this. It does work. So this is much more cleaner, and this means okay, dereference it. right? So that means, okay, we have the address now, dereference to the address, and this is much more cleaner, so to speak, I would say. This could also be useful in writing functions return. This could also be very useful in writing functions that return function pointers such as the following. So we have a function over here that um, so I think what is opening over here is this thing is returning as a function that takes that returns an int while taking two ints as an input. While itself it takes this as a parameter. So you can say if code is equal to plus plus return add sum add difference. The above function takes a char as an argument and returns a function pointer of type ptr as defined above based if it's a char or not. We can simplify the convert definitions as follows. So this returns a ptr that is much more cleaner, right? And if you were to refer to what is ptr, um, what is essentially ptr, you check that, oh well, ptr is nothing but a function pointer that takes an int, right, and takes two ints as an parameter, so to speak. We use the convert function as following. So we have int star pointer pointer or pointer if you have type def. We say ptr is equal to convert plus so essentially this returns a ptr function, and you say print ft ptr 2 by 4. Yeah, this makes sense. Yeah, this makes so the way this works is you say, okay, this is going to return fptr convert jar code if code is equal to, sorry, not that, my bad, if code is equal to plus, कुछ हम लोग करेंगे, else कुछ करेंगे, right. So what we could do is we could return add sum, and over here we could return something like add difference of some sort, uh, add some sort, right? And again int diff int a. Okay, so now how to use this? So I think we'll do something like this, convert, because we know to return that. So and so we can say dereference it and turn on this. Actually works. That's crazy. um, so we just change this, and it based on that it automatically chooses a different function to work with. That's so crazy, right? Think about it. Like this returns a function pointer depending on what it is, and then we can just run that function pointer. The only constraint that we have is the function pointer needs to be of some, has to have a definition of this. That means it will take an int and return take an int and it take it in two ints. Passing function pointers. Okay, chat, I will have to sleep. I'm a bit tired. I will do this tomorrow morning, I promised you guys, but I'm very tired right now, and yeah, I'm gonna sleep. Thank you for tuning in for another late night coding session. We did FastAPI, we did a bit of C. I know we have to do Go as well, but yeah, you'll get to that. See you later, alligator.